Today is our last lesson before our third test. So we're going to talk about some properties of log functions today. We had an intro to log functions Monday. Friday we'll have a review class for test 3, and then Monday we'll have test 3. It's going to cover classes 25 through 37. So 25 was the first class after the previous test. So we're going to start with quadratic functions, a whole bunch of classes on polynomial functions. Then we had rational, exponential, and logarithmic. And I'm going to give you quiz 6 as a take-home. I'll hand that out today. Do not leave without one, right? If you get up and leave early and don't take a quiz, I won't take it. I won't give you one. Okay. Okay, so let's look at some properties of logarithms. All right, so our preview exercises are basically just a little review here. Okay. All right, log base 2 of 32, right? So let's just refresh what a logarithm is. The little number, the little subscript number, is the base of an exponential equation. The thing on the other side of the equal sign is your exponent, because logs are exponents. So I'm saying, well, log base 2 of 32 equals what? Right? So an equivalent question would be to say 2 to the what equals 32, right? So my base is 2. The exponent is the other side of the equal sign, is what I don't know, equals 32. All right, what do you raise 2 to make 32? The fifth, right? So my answer is just 5. Okay. Log base 2 of 32 equals 5. I'm going to write that out, actually. Log base 2 of 32 is 5. All right, what's log base 2 of 8? 3, yes, because 2 to the third gives you 8, right? So log base 2 of 8 is 3. What's log base 2 of 4? 2, because 2 to the 2 gives you 4. And 3 plus 2 is 5. Okay. Now, look at your answers to 1 and 2. They're the same, right? You get 5 in both of them. How are 8 and 4 related to the number 32? They're factors. 8 times 4 is 32. All right, so what can you conclude about log base 2 of 8 times 4? They're the same thing, yeah. So log base 2 of 8 times 4 can actually be calculated by looking at log base 2 of 8 plus log base 2 of 4. It looks kind of like the distributive property, right? But that times in between the 8 and the 4 turned into a plus when I was doing the logarithm. And in the lesson, we'll talk a little bit more about this. All right, what's log base 2 of 16? 2 to what power gives you 16? Fourth power. Okay. What's log base 2 of 32? 5. Good, because 2 to the 5th is 32. Minus, what's log base 2 of 2? 1, because 2 to the 1st is 2. 5 minus 1 is 4. So look, you get the same answer for questions 4 and 5. They both came out to 4. Okay. How is 16 related to 32 and 2? Sure, 16 times 2 is 32, or 32 over 2 is 16. Yep. So if I want to take log base 2 of 32 over 2, right, it looks like you can calculate that by subtracting log base 2 of 32 minus log base 2 of 2. Okay, so again, it looks kind of like distributing, just like with number 3 here. We had the log of a product became the sum of 2 logs. So it looked like distributing, but the multiplication turned into addition. This one kind of looks like distributing, but the division sign turned into a subtraction. All right, log base 3 of 81. 3 to what power gives you 81? 4. What's 2 times log base 3 of 9? So it's going to be 2 times Log base 3 of 9. Are you answering the whole thing? What's just log base 3 of 9? 2. Yeah. Because 3 squared is 9, and then 2 times 2 gives you 4. Look, we got the same answer, right? So how is 81 related to 9 and a 2, right? 81 is 9 squared, right? So instead of taking log base 3 of 9 squared, right, I could do it directly and I'd get 4. Log base 3 of 81 is 4. But log base 3 of 9 squared is the same. You get the same answer if you do 2 times log base 3 of 9. So it looks like you can just take that exponent and put it down in front, and you'll get the same answer. So that's another important property of logs we'll go over more specifically in the demo. This is just to give you a little taste. One more property of logarithms. Log base 5 of 125. 5 to what power gives you 125? The 3. Good. All right, so I want to use a calculator to evaluate the ln of 125 divided by the ln of 5. So if you didn't get all the way to the end of your activities last class, you probably didn't use any log buttons on your calculator. On a graphing calculator, they're on the left here. We have log base 10 and log base e, right? The common log and the natural log. And if you have a scientific calculator and you have trouble locating them, just let me know and I'll come over and show you. Okay. So I've got the ln of 125 divided by the ln of 5. Oh my gosh, I get 3. Same answer I got when I did log base 5 of 125. So let's use the calculator again. This time I'm going to use the common log. Log of 125 divided by the log of 5. Three again. So this is what we call the change of base formula. We love it because our calculator only has 2 base logs on it. You can do base 10 and you can do base e. So if I give you a base 5, you can have your calculator calculate it by using the change of base formula. You can change it to any base you want. We're partial to e and 10 because those are on our calculator. But it turns out if you want to take log base 5 of 125, you can change it to any base you want. You can change it to log base anything. Call this b of 125 over log base anything you want, 5. As long as you do the same base on the top and the bottom, you can get the answer this way. Okay, so you could do ln, you can do log base 10. So logarithms have all kinds of interesting arithmetic properties. Right? That we are going to explore a little bit further. These are the 4 properties, okay, listed out with symbols, not just numbers. Okay. If you want to take the log of a product, you can take the sum of the 2 logs. Okay. So the log of x times y is the log of x plus the log of y. Looks like you're distributing the log to the x and the y, but that multiplication sign in between the x and the y turns into a plus. And then we have an analogous property for division, right? The log of x over y becomes log x minus log y. If you want to take the log of x to a power, you can bring that p, your power, down in front of the log and change it to multiplication. This one is really, really handy for solving equations, which we're going to be learning how to do after the next test. It's a really handy one. And then we have the change of base formula. If you have log base anything of x, you can change it to any other log you want by doing the division, log of x over log of b, with any base you want. All right, so we're going to use these properties, now that we know they exist, to expand and condense some expressions. So let's look at log base 5 of 25x² times z over y cubed. I want to expand this, right? So make it bigger. So often when we say simplify things, we want you to condense as much as possible, but now we're expanding. So in this expression, 25x² z over y cubed, I see all three of these first three properties. There are multiplications, 25 times x² times z, right? So I can apply property 1. I've got a division, which means I can apply property 2. And I've got some powers in there, which means I can apply property 3. So my advice is going to be one at a time. So let's apply property 1, the multiplication one. Or actually, I think let's do the division first so that we can just get rid of the fraction, because fractions just make everybody nervous, right? So if I do the division one first, this is going to become log base 5 of 25x² z minus log base 5 of y cubed. So I took the log of the quotient and it sort of expanded into a subtraction. Take the log of the top and the log of the bottom and subtract them. All right, let's just work on this first logarithm here. Log base 5 of 25x² z. This is a product. In fact, there are two products there. 25 times x² times z. So I'm going to apply rule 1 here, property 1, twice. So this is going to become, I'm going to start over here because it's going to get long. Log base 5 of 25 plus log base 5 of x² plus log base 5 of z. And then I'm just copying this last thing from the previous line, log base 5 of y cubed. All right, so everything seems to be within each log. There are no more products or quotients, right? There's no more multiplying or dividing like within the parentheses. But I do have rule 3. I do have some exponents that I can apply my rule 3 to. Right? If you have the log of something to a power, you can take that power and write it in front of the log. Okay, so let's just do each one of these separately. First of all, what is log base 5 of 25? 2, because 5 squared is 2, right? 5 squared is 25. So we get 2 here. Okay. Log base 5 of x², apply property 3 that says you can take the power and drop it down in front of the logarithm. So this becomes plus 2 log base 5 of x. Log base 5 of z, there's nothing I can do there because there's no power on the z. So this becomes log base 5 of z, it just stays the same. And then I can do property 3 again because I have an exponent. Taking log base 5 of y cubed, I can take that 3, put it in front, and I get 3 log base 5 of y. So that's the expanded form, right? I started with this nice condensed single logarithm and I expanded it out using my rules. We can do the reverse, right? I could start with something all expanded out, written as several logarithms, and I want to condense it, pull it all back together into a single logarithm. So let's do an example like that. All right, I've got this expanded logarithm. I have 3 different logarithms show up in this expression. I want to condense them all into a single logarithm. So let's deal with the exponents first. Like whenever I have a number in front, you can pop it up back into the exponent, right? This is just the reverse of the power rule, right? If it's down in front, it can go back up. If it's up, it can come down in front. So this is going to become log base 4 of x cubed plus log base 4 of z squared minus log base 4 of w to the 1/2. All right, these first two logarithms are being added together. So if I was going to squish them back into one logarithm, how do I combine the x cubed and the z squared? Multiply. Very good. So I'm just going to combine these two, one rule at a time here. X cubed z squared minus log base 4. Instead of w to the 1/2, how could I write that? How could I rewrite that if I wanted to? No, good guess. Square root of w. Yeah, square root of w. Same thing. Because remember, whenever you have a fractional exponent, the number on top of the fraction is a power and the number on the bottom is a root. Nope, either of those is accepted. You can leave it as w to the 1/2 if you want. Square root of w is just a more common way of reading that, but it doesn't matter. Okay, now I have two logarithms left. They're being subtracted, so I can squish them into one logarithm by dividing the inputs. Yeah, so this becomes log base 4 of x cubed z squared over the square root of w. Okay, so we've got these four properties of logarithms. Those first three are used to expand and condense logarithmic expressions. Okay. Why do we do that? It can be helpful when you're solving equations, right? Just to be able to write things in different ways can be helpful when you're solving an equation, which again, we'll do after the test. Okay. The last property is super helpful because it allows you to evaluate things like log base 4 of 50 really accurately. So log base 4 of 50 is asking you to answer the question 4 to what power gives you 50? But there isn't an integer answer, right? You could say, well, 4 cubed is, 4 squared is 16. 4 cubed is 64. So it's somewhere between 2 and 3, right? 4 squared is 16. 4 cubed is 64. I jumped right over 50, right? So 4 to what power gives you 50? It's got to be somewhere between 2 and 3. But my calculator will give me a really, really accurate answer if I use the change of base formula, right? I can do log base 4 of 50 by using any base I want. And I'm going to use E because E and 10 are buttons on my calculator, and E is faster to write ln than it is to write log. So I'm going to use ln. Okay, so ln of 50 divided by the ln of 4. Okay, so, and I should use a squiggly equal sign here because I'm going to round an answer, so it's approximately equal. So the ln of 50, oops, close that parentheses, divided by the ln of 4, 2.82. Approximately 2.82. So that kind of makes sense. It's between 2 and 3. It's closer to 3 than it is to 2 because 64 was closer to 50 than 16 was. And then we can check it. We can check that if you raise 4 to that number, 2.82, we should get 50. So let's try 4 raised to the, I'm just going to hit second answer. It just uses the previous answer. And I get 50. Or you could retype it too. You could do 4 to the 4.82 and it 2.82. 4 to the 2.82. And I get really close to 50. Why doesn't it give me exactly 50? Because I rounded that number. 2.82 is a rounded number. Right. Any questions? All right. Work on some activities.